And the final question, question 8, is quite a long sort of unknown question where you've got to work out what the various organic compounds are given all this information. So we're told compound B, CXHYO, can be oxidized to form a ketone. So straight away you need to be thinking, right, well, B must be a secondary alcohol because secondary alcohols oxidize to ketones. You're given 0.035 moles of B has a mass of 2.59 grams. So if we've got moles and mass, we can work out the MR of B. And then compound B reacts with compound D. We're given the molecular formula of D in the presence of an acid catalyst. So we already know B is a secondary alcohol, acid catalyst. So that's got to be talking about esterification. And so therefore D is going to be a carboxylic acid because alcohols react with carboxylic acids to form esters. So one of these must be an ester. And obviously the other product that's formed when you have the esterification reaction is water. So that's all sort of been processed in our heads. Let's go through working out what the actual structures are. So first thing, calculate the molar mass of B. I've kind of already mentioned how to do that. So the MR of B is the mass over the moles. That's your 2.59 over the moles, 0.035. And that comes out at 74 grams per mole. We've established that B must be a secondary alcohol. So to be a secondary alcohol, it's got to have a carbon with an OH group attached with 2 carbons directly attached with a hydrogen on there as well. That gives you 54. So we've got an MR of 74. So we need another 20 grams worth of atoms. And so you set about working out, well, what would I need to add to this structure here to get me that 74? And it comes out as this structure here adds up to 74. It's got that secondary alcohol bit, which it must have. So B must be butan-2-ol. C is the oxidation product of B, which is a ketone, so it's going to be butanone. D is the compound that reacts with B to form the ester, so D is propanoic acid. And then I'm going to go for E being the ester, so we're reacting this alcohol here with this carboxylic acid here, and so we're going to get this ester where it's kind of joined at 90 degrees. It's not like a long chain ester, which you normally get if you have carboxylic acid and primary alcohol. This is a secondary alcohol, and so the alcohol is going to add this way. So that would make F water. Compound G, so part B now, compound G is a branched chain organic compound that does not have EZ isomers. So we're assuming here now that it's going to be an alkene, and because it doesn't have EZ isomerism, one of the carbons of the CC double bond must have the same groups attached, otherwise it would be able to have EZ. So we're given an elemental analysis. So we've got composition by mass. We'll be able to work out the empirical formula from that. We've got a mass spectrum. Most important peak on here is the one with the highest M over Z value. So that's given us the MR of G, which is 86. So I would encourage you to annotate your spectrum as you go through, work through the paper. And we're given a couple of fragment peaks labelled up X and Y. So we'll come back to them as we get into the question. The infrared spectrum of G, well, you can see this broad absorption around about 3000 centimeters to -1. So we've got the OH of a carboxylic acid and there's confirmation that this must be a carboxylic acid. So G is a branched chain, looks like a carboxylic acid, and it's got a carbon-carbon double bond in it, which must have the same groups attached to one of the carbons. Okay, so let's try and process all of that. So the empirical formula of G, well, there's the working out for that. So it's just the percentages divided by the MR of each atom, and we get the mole ratio, and then we simplify it to the simplest whole number, mole ratio C2H3O. The mass of that is 43, but we know the MR is 86. So there's obviously twice as many atoms in the molecule, so the molecular formula must be C4H6O2. We've already established that G is a carboxylic acid, so see the annotation on the spectrum. So then we've just got to work out a possible structure. So G looks like this. It fits the MR, it fits the carboxylic acid, and the double bond must be here, otherwise it would be able to exhibit EZ isomerism. So these two hydrogens on this carbon here are making EZ not possible. What are the peaks at Y and X? So the M over Z value at Y is 45. So that is due to the COOH plus fragment. So it's obviously broken here in the mass spectrometer. Everything in the mass spectrometer must have a positive charge. So it's COOH plus. And the peak at M over Z of 41. So we're looking at all the rest of the molecule. So it's this fragment here. So it's CH2 double bond C, CH3 plus.